Welcome back to our channel. Today, we're diving deep into some of the most mind-bending discoveries made by the James Webb Space Telescope. This new data is challenging the very foundations of what we thought we knew about the universe, specifically, the Rayonization model and the universe's expansion rate. This is big, as it opens up endless new questions and theories in astrophysics. A declaration from Carlos, an educator dedicated to cosmology, astrophysicist and educator Carlos states, "I've spent my whole career studying a specific model of the universe. Now, as new data comes to light, I embrace the challenge." Scientific inquiry thrives on this kind of exploration, reshaping our understanding. For decades, we've operated under certain assumptions, but James Webb's data may force us to reconsider everything. This is science in action. Carlos embodies a spirit of curiosity that's essential to the field. But what exactly did the telescope find that's causing all this upheaval? Shattering a century-old model, the James Webb Space Telescope is stirring up some long-held theories in cosmology. Initially, this telescope was designed to reveal the universe's earliest stars, but it's become much more than that. Webb is showing us images and data that call into question models held dear for over a century. Let's take a look at one particularly controversial area, the early universe and cosmic rayonization. For a long time, we've thought the universe became transparent to light about 380,000 years after the Big Bang, when protons and electrons combined to form stable hydrogen atoms. This shift, known as rayonization, allowed light to travel freely, creating the cosmic microwave background, CMB, we observe today. But new observations show structures and formations that seem too advanced to fit our current models, suggesting either our timelines are off or the processes involved may be vastly different than we thought. This data is so controversial because it questions not only rayonization but also our understanding of dark matter, dark energy, and the expansion rate of the universe. Expanding rayonization, the universe's first light. The term rayonization might sound like another complex scientific word, but it's a milestone in cosmic history, marking the moment when the universe transitioned from darkness to light. Scientists have long theorized that this era began when the first stars and galaxies formed, emitting enough energy to rayonize hydrogen, stripping electrons from atoms and allowing light to travel freely. This process changed the very structure of the cosmos. But what if this didn't happen in the neat, uniform way we imagined? That's the question the James Webb Telescope is posing. Instead of smooth, gradual rayonization, the data reveals clumps of intense, rapid formation. Structures are forming earlier than we thought possible, leading to questions about how such dense formations could come into existence so soon. This revelation means our timeline of the early universe might be off. For decades, rayonization was understood as a key phase in the universe's evolution, one that laid the groundwork for galaxies as we see them today. Now, we're being forced to question that very foundation, which opens up endless possibilities but also leaves a gaping hole in our understanding. Why James Webb is uniquely positioned to uncover these secrets. To grasp the weight of these discoveries, it's essential to understand the telescope itself. Launched in 2021, the James Webb Telescope is not just an upgraded Hubble. It was designed with infrared capabilities that allow it to peer deeper into space, and therefore further back in time, than any telescope in history. By capturing infrared wavelengths, Webb can observe the faint light of the universe's earliest stars and galaxies, which are billions of light-years away and heavily redshifted. The importance of Webb's unique ability cannot be overstated. While Hubble brought us incredible visuals of nearby galaxies, Webb is reaching an era when the first light formed, capturing events nearly 13.5 billion years ago. In doing so, it's unveiling the cosmos' deepest secrets, one observation at a time. But the further back we look, the more it seems our cosmic history is filled with mysteries we haven't even begun to solve. Dark matter and dark energy, the unseen forces in the cosmos. Now, let's introduce another cosmic puzzle that these findings touch on: dark matter and dark energy. For decades, scientists have struggled to explain these mysterious forces that seem to govern the universe's behavior. Dark matter, the invisible scaffolding that holds galaxies together, and dark energy, the force driving the universe's expansion, are essential pieces of our cosmological model. Yet, James Webb's findings may be forcing us to revise these concepts too. With structures forming far earlier than expected, the gravitational pull of dark matter may not work as we thought. Could it be that dark matter behaves differently in the early universe, or that it interacted with regular matter in ways we haven't yet understood? And what about dark energy? Observing galaxies from Webb's perspective means we're looking back through billions of years. If galaxies are clustering together differently than we expected, it could mean that the universe's expansion rate varied over time. This raises the possibility that dark energy might not be a constant force, as we once believed, but something that evolved alongside the cosmos. These revelations might mean rethinking the very nature of the universe. If dark matter or dark energy works differently than we thought, we may need a complete overhaul of the cosmic model, paving the way for new theories, possibly even new particles or forces. The future of astronomy, rewriting the textbooks for generations, scientists have relied on a framework based on Einstein's theories, supported by decades of observation and experimentation. But every new discovery from the James Webb Telescope seems to bring us closer to a crossroads. Are we approaching a revolution in our understanding of the universe? If so, the next few years could be some of the most exciting in astronomy's history. Imagine textbooks rewritten, documentaries filmed, and minds ignited by the mysteries Webb has yet to uncover. Every discovery reshapes our place in the universe, and Webb is uncovering a cosmos far more dynamic and